Good morning, class. So in this live lesson recording, we're going to be going over Unit 6, Lesson 7 notes, which is the Pythagorean theorem in 3 dimensions. So what we're going to be looking at is, up to this point, we've been using the Pythagorean theorem in only 2-dimensional triangles. So again, we're talking about right triangles. So draw a little quick picture. So a triangle is 2 dimensions, but what we're going to be talking about now is how you can use the Pythagorean theorem when there's a 3-dimensional figure, like, say, a pyramid or a rectangular prism. So that's what we're going to be talking about today, because you can sometimes use the Pythagorean theorem to solve for certain distances or heights or things like that within 3-dimensional figures. So we'll jump into that here in just a second. So just a reminder, the Pythagorean theorem is a squared plus b squared equals c squared. So remember, the a and the b represent the sides that are next to the right angle. And again, Pythagorean theorem only applies to right triangles. Okay, so this is a and b. They are the legs. They are the two sides that are adjacent or next to the right angle or make up the right angle. And then c is always the hypotenuse, which is the angle opposite of the right angle. So as just a reminder, b and a, it doesn't matter which one you call b and which one you call a. So you can flip-flop these if you want. Doesn't matter. So with that, we're going to go ahead and jump into question number 1 here. Oh, sorry. Yawning a lot. Use the Pythagorean theorem to determine the height of the pyramid H. Okay, so first of all, we're looking for this, and you can see that they kind of give us a hint here that we need this distance right here and this distance right here. They already give us this diagonal here, which is the hypotenuse. So remember, the side opposite of the right angle is the hypotenuse. So the hypotenuse is 25. Now, this entire length is 40. Well, the distance from the peak of the pyramid to the side is half of that. So it's like half that distance. So this would be 20 feet. So now we have two sides, and we just need to figure out what this height is. So we're going to use, remember, we talked about in our previous live lessons that whenever they give you the hypotenuse, you can do a shortcut. Instead of doing a squared plus b squared equals c squared, you can use this formula. C squared minus a squared equals b squared. So in this case, the b would represent the height. So we could just kind of equals b. So b equals the height. Okay, so our hypotenuse, or c, is 25. So that's 25 squared. And our leg is 20 squared. Well, it's 20, but then we have to square it. Okay, and then 25 squared, I believe, is 625. And 20 squared is 400. And that's going to be equal to b squared, or the height, squared. And then 625 minus 400 is 225. Is equal to b squared. Now, just so you know, I could have just plugged this all into Desmos, so watch what I do here. I'll just show you kind of like the shortcut to do this in Desmos. So what I could have done is just do 25 squared minus 20 squared, and I get 225, and then you just take the square root of that. So that's kind of like the shortcut. So square root of 225 is 15. Okay, so back to here. Okay, so the next step then is, like I said, square root, because the square root cancels the square, and you get just b by itself, because squaring and square rooting are opposites. So they cancel each other out. And then the square root of 225 is 15. So that height is 15 feet. So 15, whoa, that is really bad. So 15 feet. All right, and that's it for that one. All right, this one, might have to actually do a little work here to figure this out. It says the height of the prism is 32, so this side right here is 32 centimeters. So that's this height right here. And all the heights would be 32, by the way. The width is 24. So that's this one here, which actually in this case is not, I don't think it's going to be helpful, but we'll just go ahead and write it in there. So 24. So this is also 24. It says the, wait. Oh, the length of the prism. Oops. I got that wrong in the first place. Okay, the height is 44. Interesting. Okay, so this is 44. The length of the diagonal of the base. Okay, so that's segment BH is 40. Okay, so this is 40. So that's this. This is 40 right here. Find the length of the diagonal. Okay, so the rest of the stuff is kind of meaningless. The only ones that matter is if we're trying to find this diagonal, the two parts that we care about are this 44 and 40, because this is what we're trying to figure out, and this is the right triangle that it's formed, and it uses this 44 and this 40. So the only one that matters are these two numbers. So again, this represents C, and we can use this as A and this as B. Now this time we don't know what the diagonal is. That's what we're trying to figure out is the hypotenuse. Okay, so this one we'll use a squared plus b squared equals c squared. So a will be 44. Again, doesn't matter which one's a, which one's b. B will be 40. And we're trying to figure out what the diagonal squared is, or what the diagonal is. All right, and then I don't know what 40. We're gonna just plug this into Desmos. All right, so 44 squared plus 40 squared is 3,536. So I'm just gonna, so 3,536 is equal to c squared, and then again just take the square root to find what c is, and this is going to be in centimeters. So we'll go back to Desmos and just take the square root of that number. So square root of 3,536 is 59 point, did it say it around somewhere? Find the length of the diagonal of the rectangular prism base B. Let me just double check to make sure I got this right, because that doesn't seem right. Length of the prism is 32. That's a meaningless number for this. I mean, we can write it in there, but we don't need that. Length of the diagonal of the base, which is this here, is, oh no, segment BH is 40. Yeah, that's right. Height is 44. Okay, yeah, so that's right. All right, so then our answer, it doesn't say to round anywhere, so we'll just go 59 point, we'll say 5. So 59.5, and then this was in centimeters? Yeah, centimeters. I'm guessing I just changed the numbers from what was actually in the quick check, and the numbers I had didn't work out perfectly like the numbers they had possibly. So I'm not really sure. But that is the correct answer for this one. All right, whoa, this is a long one. Okay, so it says Chemtech makes paper cones to filter liquids in lab experiments. To make paper cones, the company starts with a net of the shape where the slant height is needed. Okay, so we need to know the slant height. The company wants the height of the cones to be 6 centimeters. Okay, so just to kind of like draw this out in, to show you what, so this would be like the part you can't actually see in the cone. Okay, so it's saying the height is 6 centimeters. So that's this piece right here. Maybe I should do this in a different color so you guys can see it a little better. Okay, so this is the height. It says that's 6. It says the diameter, which is all the way across, is 13 centimeters. We only want half that distance, so we're going to do 6.5. We want the radius. Okay, and then what we're trying to figure out is the slant height. So the slant height would be this piece. So this is how we have our right triangle. Okay, and we have our two legs, so 6 and 6.5, and we're trying to figure out what this height is, which again is our hypotenuse, or we call it C, which is the slant height in this case. Okay, so we're going to use the a squared plus b squared equals c squared, so that's going to be 6 squared plus 6.5 squared equals c squared. This one is definitely going to be a decimal answer. Okay, so we're going to go to Desmos and figure out what this part is. Plug it into the calculator. So 6 squared plus 6.5 squared is 78.25. So this is 78.25. And again, our last step is always to take the square root of that number to get c by itself. So square root of 678.25. So 8.25 is 8. We'll just round it at 8.85, we'll say. Now, if this were a company making something that was important to make, and how precise they were was important, then they'd probably round way back here. But for our sake, we're not a company making something, so we're going to say 8.8. We'll round it to 8.85. We'll go to the nearest hundredth. They didn't tell us where to round to, so we'll say 8.85 centimeters. And that is our slant height. All right, it says a circus tent and is in the shape of a square pyramid. Okay, so that would be like what we had in question number 1. I don't know if this was a square pyramid necessarily, but it would be a pyramid like that where the base is a square. Okay, and then it says each edge of the square. All right, so I'll just kind of draw this out. So here is, this is not really the best way to do this, but I'm terrible at drawing pyramids. But all right, so it says each side is 20 of the square pyramid. So 20, 20, 20, and then that side's 20. All right, because it's a square, right? It says the slant height is 13.5, so that would be along this diagonal. And it wants us to find the height. So that's here, going through the middle. And again, we can draw our right triangle. So if we know that this side is 20, then the distance to this point right here and here is half of that, so that's 10. Okay, and then we know the slant height is 13.5. I should do this in different colors. Why do I keep doing the same color? I just want you guys to be able to see the actual triangle here. All right, so here is our height. That's what we're trying to figure out. We know the slant height. That's 13.5. Sorry, I'm drawing that super tiny. And then this is 10. So the part we don't know is one of the legs. We know the hypotenuse, right? That's this one right here. That's slant height is 13.5. So this one we're going to do the subtraction problem because we know the hypotenuse. So we're going to do 13.5, that's our hypotenuse, squared, minus our leg squared, and that's going to be equal to the other leg, which is our height in this case, squared. All right, and then I'm just going to plug this part into Desmos. So 13.5 minus 10, 13.5 squared minus 10 squared is 82.25. And again, I'm going to take the square root of that to find the height. All right, so square root of 82.25 is 9.07, we'll say. We'll round it to the nearest hundredth, I guess. So 9.07. And in this case, it's 9.07 meters. What is this for? Oh, a circus tent. So 9.07 meters is like 30 feet tall, so that would make sense for a pyramid. For a tent, anyways. And if it's 20 meters long, that's like 65 yards by 65 yards. That's a big tent. All right. Question number 5. It says, Melissa has a gerbil that lives in a cage in the shape of a rectangular prism. She wants to put on a ramp in the cage to give her gerbil exercise. The cage has a length, width, and height. So here's the length, width, and height. How long does the ramp need to be to fit diagonally in the cage? This is kind of a weird question because it would make no sense to make a ramp like that. Because if you think about what what that would look like. It would just be weird. So like imagine this is the cage for the gerbil, right? It's saying the ramp would go like this across the cage, like I don't know. That would be weird. I don't know why you'd want that, but anyways, it's math, right? Okay, so what we're trying to figure out is the diagonal. So here is kind of like a little. I'm going to give you a little shortcut. Anytime you're trying to find the diagonal across a rectangular prism, and it gives you the length, height, and width. In this case, we could have done the same thing, but we didn't. But if it gives you the length, height, and the width, we're going to do something a little bit different. So this is if you're just trying to find the diagonal of a rectangular prism, and it gives you the length, height, and width. So I'm going to give you a different formula that you can use whenever it gives you that specific situation. It only works in this specific situation. Okay? So normally our formula is a squared plus b squared equals c squared. But for this one, we're going to do a squared plus b squared plus c squared equals d squared, where d represents the diagonal. So d in this case is the diagonal of a rectangular prism. And then a, b, and c represent the length, height, and width. And again, it doesn't matter which is which. So it doesn't matter which one you call the length, which one you call the width, which one you call the height. Doesn't matter. So a, b, and c represent the length, height, and width of the rectangular prism. D represents the diagonal, which is what you're trying to figure out in this case. Okay, so again, doesn't matter what order I put these in. So 70 squared plus 50 squared plus 35 squared equals our diagonal squared. Okay, so now we're just going to plug it all into Desmos. So it's going to be a really big number. 70 squared plus 50 squared plus 35 squared. Those are our three sides, our length, height, and width. So that's 8,625, not quite as big as I thought. That's 8,625 is equal to our diagonal squared. And again, last step, take the square root. So our diagonal is the square root of 8,625. So that's 92 point, we'll round to the nearest hundredth, so 92.87 centimeters. 92.87 centimeters. And that is the length of the diagonal of the cage for this gerbil. All right, that's it for lesson number 7. So just as a reminder, for lesson 8, here I'm going to move some stuff around so you guys can so I can actually click on this. All right, so for lesson 8, we do have a portfolio. There is already a recording available. It's a recording from last year, so I'll probably make a new one anyways. But there is a recording there available for those of you that are already on it. And this is the actual portfolio that you're going to complete. And then for lesson 9, the sample work has been dropped, so you don't have to do anything for that one. I've also dropped the test, so whenever we do a portfolio, I drop the test, so there is no test here as well. You will still have to do the practice, though, so that's this one right here. Oh, but it doesn't, hold on, maybe I did drop the practice. Let's see, did I drop it? It's dropped. I'm going to drop it. Even if I didn't drop it before, I'm going to drop it now. So the only thing you'll have to do is complete the portfolio when you get to lesson 8. After that, the rest of the unit will be dropped. So the sample work, the practice, and the test, and then you'll move on to lesson or chapter 7 or unit 7, I guess. All right, have a great day, and if you guys have any questions, feel free to reach out.